Hello, I have here a simple lift and I'm going to write a simple application in STL for this lift because I want to illustrate elements of STL which was in previous lesson. So it will be simple application based on set, reset, end operation or operation, and simple assignment. So have two sensors for safety, which will off our lift. The lift cannot go here, because if lift reach this position, something was wrong. For example, this sensor will not detect that the lift is here. So the lift will achieve then extremely positions, but we cannot allow the lift to do that. So generally the sensor are for detect a platform. The platform is made of metal, and the platform goes up when we have a signal from this conveyor that the pack is ready. We also generate a signal for this conveyor if the pack is ready to get it by this conveyor. So when lift achieve this position or this position, it is good, but if achieve this position or this position in red color, it is a bad situation and we want to avoid that. So how it look like in simple steps: the pack is going there, we have a signal that we can go up, and we are going up. If we achieve this position, we generate a signal for conveyor that the pack is ready. So let's see how it works in STL. I have here a schematic manager and I need a function block for my lift. It is FB1. Of course I need an instance block, so this is my instance block for storing data. Okay. One moment. The window is opened and we can write a program. First we have to know what kind of variables we need, and we have 4 sensors, so we need simply 4 input variables. It is sensor at ground floor sensor, first floor sensor, and 2 safety sensors. So safety sensor 1 and safety sensor 2. We have also 2 signals from conveyor at the first floor and ground floor. It is information that the pack is ready for lift, or the pack is outfitted from the lift. So we have 2 feedbacks, and I will call it ground floor feedback and first floor feedback. Okay, next we have to add output variables. We have 2 output variables because we have only 1 motor and we want to control this motor in 2 directions. So it is motor up, and motor down. We will use also edges in the project. I will show you the basics of edges because this is very simple in 2 seconds. We have edges connected with first floor sensor and ground floor sensor, so I will add it now and explain it later. It is first floor sensor positive edge and ground floor positive edge. Ground floor positive edge. Okay, there are static variables, and let's see again. We have input, output, and static variables. It should be okay. So let's write a program. We have to control a motor, and let's see a condition for a control of motor. I have to get a feedback from ground floor conveyor to start my lift, and I need to have a platform lift at sensor ground floor. So this is a condition for these 2 sensors. For sensor and for feedback, it is ground floor feedback and ground floor sensor. Of course, this is A. Then I will start a motor. The same is for first floor. So if I have first floor feedback and first floor sensor, I can start motor down. What if lift is at sensor of safety? We have to stop the lift, so reset motor up and reset motor down. So simply the condition is that if safety sensor 1 or safety sensor 2, we have to reset motor up and reset motor down. And now edges, because we have here in code detecting of signals without edges. We should to use edges in next part of program to properly detect when the lift is actually at the sensor first floor or sensor ground floor. So it seems like that. This is a logical OR condition, and to detect from OR AND the edge, we have to simply write FP and write our variable for storing edges. So in my case this is first floor sensor positive edge, and I am detecting a positive edge here from this variable, but I am storing a result here. So I can write here A, and this is the same because we are detecting a positive edge from this variable. I know that I have OR operation below, so I am writing O as a first letter, because I have here also, as you know, second similar sensor, it is ground floor. and this is the same situation. I have to detect positive edge, so I use FP GFSR positive edge GF. Oh, here's a mistake. GF positive edge SR, of course. Okay, that's okay. And in this case we have to reset our motor. Let's see in help how look like description of positive edge. We have RLO equal to 1 if we have a positive edge at this variable, and this is the result. Logic operation is stored here, so this is our variable for storing data. Once again, let's see the description and help. During each program scan cycle, the signal state of the RLO bit is compared with 2 obtained in the previous cycle to see if there has been a state change. So we have a comparison of 2 bits in previous cycle and in actual cycle. So we can use for it simple markers also, but this function helps us to avoid that. Yes, this is the comparison. If there's a difference between these 2 bits from previous and actual cycle, there is positive edge or a negative edge. It is depend on what we want to detect. Negative edge is simply another function. So for negative edge we have Fn, but for positive edge we have Fp. Okay, the program is finished. Let's see how it works. I will open PLCSIM. But first I have to add a program to OB1, so I will also open OB1. I'm not sure that the program is saved, so I will open again FB1, save it. Yes, it was not saved. This is the information, this pop-up window before that we have changed something in the variables here. So the interface of the block changed a little bit, but it doesn't matter for us because we will use in OB1 the call first time. So I will write the call for FB1 with my data block. This is DB1. The timestamp of the instance data block DB1 is different from the assignment. FB, do you want to generate the instance data block again? Yes. So we need to add here our variables. I will use physical input variables for sensors and physical output variables for feedbacks. 0, 1. This is only variables for illustration, so this order should be okay, but feedback is okay. 0.5 motor up it is Q0.0 and Q0.1. That's right. I will save it, open manager and download it to PLC. Yes, yes, okay. And now I have to see control of my program, but I have to see here symbols. So I have to attach the symbols, but I need to create it firstly. In symbols, let's open the window of OB1 to see how it calls. One moment, because okay, the window is here. I will move the PLC sim because I don't need it now. Okay, so GFSR address 0.0, next FFSR, next SFSR1, SFSR2, next feedbacks, okay, and motor. Okay, Control S, and now I can attach our symbols to PLC sim. Let's find it. Source block blocks in S7 program. Okay, but we have to add our byte to observation. It is input byte 0. Yes, the variables are added, but I have to change the outputs because motor is not input, it is output. One moment. And output also 0, so this is of course Q. Control S, and now okay, it's okay. Let's see how it works. So let's consider first situation that the lift is at the ground floor. So we have a ground floor sensor, and the lift is waiting for a signal from a conveyor. So I will provide the feedback now, and the lift should go up. Okay, the lift is going up, but of course the symbols are still wrong. One moment. This input and sorry, it is 1, 0 and 1. Now it's okay. Let's start. So motor is up. Now the lift is going for sensor first floor. If it reached the sensor, this is why I used positive edges, and motor is turned off. When I will provide a feedback that the pack is outfeeded from the lift should go down. So let's give a feedback. This is first floor feedback, and the lift is going down. And this is the same situation. It will stop when we provide a signal from GF sensor. Okay, so everything is fine, but let's see how works safety sensors. So let's send a lift upstairs again. It is ground floor sensor needed and feedback. Okay, and now let's simulate the sensor 2 as I remember, and the lift should stop. Generally it should stop if I select sensor 1 or sensor 2. So let's see sensor 2. Yes, the lift doesn't work now. The lift doesn't work now, so everything is okay. And next video I will write a program for conveyors and develop a lift in STL. So I will write a manual mode and auto mode, so please follow and write a comment. Thank you for watching.